The construction of the synchronous machine actually consists of two main parts, the stator and the rotor. So the rotor of synchronous machine represent a large electromagnet. So as we said, the field winding are placed on the rotor and the armature winding are placed on the stator. So we have two types of the rotor here. One we call it non-salient pole or cylindrical or round type, as we can see in this figure here. So the round type or usually is used with the high-speed machines. So it consists from a small number of poles, either two poles or four poles. So in the case of the two poles here, we have the speed will reach to 3000 RPM. In the case of four poles, the speed will be 1500 based on the formula of NS here. Actually, the NS is equal to 120 F over P or over the number of poles. So if we want the speed to become 50 hertz, so we are the frequency to become 50 hertz. So the 50 will be here. So the speed will become 3000 in the case of the two pole, or become 1500 in the case of the four pole. So this we call it the cylindrical or round rotor type, and usually is used in the gas power plants which required high speed turbine. Okay, the second type we call it salient pole, and the salient pole here consists of multiple several multiple poles, more than four poles. So since the number of poles is high, so the speed of the such machine is become lower. So as we can see here, if we have 12 poles, so the speed become 500 based on the previous formula, or we have 24 poles, the speed become 250 rpm. And this type of rotor here of the rotor is used with the low power or the power plant which required low speed turbine. So in the case of the hydroelectric turbine, for example, we this type of rotor is preferred. Okay, so as you can see here, the rotor made of laminated plates here. So you can see how the design is looks like for the poles of the rotor, and all this to decrease the magnetic flux loss and also to reduce the eddy current losses. So this is the how the cross sectional of the synchronous machine or synchronous generator, and this synchronous generator or synchronous machine with a brushless exciter. So you can see here the brushless exciter system is placed on this part. So as this part represent actually the here, this part represent the exciter that we talked before about it. So the exciter is placed on the same camshaft. This is the camshaft actually go inside the machine. It has or the exciter and also the rotor of the machine both are placed on the same camshaft. So the exciter here is got the power, AC power, convert to DC to the stator winding. Then in rotor winding it will induce voltage which is AC. Also it has a rectifier, convert to DC, then it's go to the rotor inside this part of the machine to produce the field current or the field DC current, which will produce the magnetic flux. So and induce the voltage in the stator part. So the rotor part is the inside part and the stator part is the static or part outside. So here also this type of poles is or this type of rotor is salient poles. Salient poles, that means it can be mini poles, and its design is allow for or use for low speed machines. The rotational speed here of the synchronous generator actually is equal to the synchronous speed. We said only the synchronous machine, it has only one speed, which is the synchronous machine, synchronous speed, and this speed is fixed or constant. So it will produce also a constant or fixed frequency. So if we have, for example, if we want the generator to produce 50 hertz or produce 60 hertz, so then we are going to select the proper type of poles and the proper speed value for the machine. The induced voltage in the synchronous stator. So we said the rotor represents the field winding and the stator represents the armature winding. So the induced voltage in the armature or E armature here is proportional with the magnetic flux generated in the field winding and also with the angular frequency or angular speed of the rotor. Okay, so the angular speed here or angular velocity of the angular speed of the rotor, in addition to the generated or the produced magnetic flux, will decide the value of voltage induced in the stator winding. So this value will be the output voltage of our synchronous generator. So as we can see here, the induced voltage is proportional to the rotor flux for a given rotor angular frequency. So for specific frequency, it will be proportional relation between the voltage and the induced magnetic flux. Okay, according to this graph here, we can see the relation this graph represents the magnetization curve of the magnetization curve for open circuit characteristic. This we call it the open circuit characteristic of the machine. So the open circuit characteristic, that means the machine is running without load, like we learned before during our test for either for the DC machine or for induction machine when we talk about the open circuit and also short circuit test. So this curve here represent the open circuit characteristic for the curve for the synchronous machine, and it's relate between the magnetic flux generated in the rotor and the field current. As we increase the field current, we said the field current come from the DC source that apply to the rotor winding or the field winding. Okay, so the field current here, as the field current increase, also the magnetic flux produced by the field will be also increased until reach to saturation point. Okay, this field voltage or magnetic flux generated in the rotor winding also will cut the air gap to go to the stator winding or to the armature winding of the synchronous machine. So in the synchronous machine, it will induce electric or electrical voltage or armature voltage here. So this armature voltage actually it's directly proportional to the field current. So as I increase the excitation current or the field current of my machine, of the synchronous machine, I will get increment in the produced voltage until we reach to the rated or synchronous or the rated voltage of the generator. Okay, and this will be at omega equal to omega synchronous. When we reach to the synchronous speed, so no more increment in the output voltage of our generator. This all about the construction of the synchronous machine. We are going to continue in the next video.